Hey guys, so I figured this probably be my last review video. I'm just going to hammer through some pollution stuff. I know it should be fairly fresh, but if I can get this in about 10 minutes, it's worth watching just to refresh your memory on, again, the problems and then solutions, where the pollution comes from, what we can do about it, and then some specific things that you may or may not remember. So I'm going to use this PowerPoint. Got my notes here too, but I'm going to just kind of rip through some of this here. So, all right. So obviously, you know what air pollution is. It's either chemicals, gases, particulate matter, microorganisms in the atmosphere, high concentrations that can harm us, plants, buildings, other animals, right? So the main ones here: sulfur dioxide, nitrogen oxides, NOx, carbon oxides, CO, CO2, and then we got particulate matter, right? So let me just go back to these quickly here and kind of hit the main points. So SO2 is mostly from combustion of coal and some oil as well. Definitely causes respiratory problems, and it can affect plants as well. It can also come from volcanoes and forest fires as well. But primarily, I'm looking at my notes. It says it right here. So, anyways, just have a good idea of where that comes from, right? NOx, NO2, NO, and NO2. Basically, again, burning any sort of fossil fuel can produce this. Forest fires, lightning can produce this, microbial activity as well. Also a respiratory irritant, and it is a precursor to ozone, and it can also form smog as well. SO2 can form smog, a different kind. We'll talk about that in a little bit. So there's NO2, again, from just in general burning fossil fuels. And the dirtier the fossil fuel, the more NO2 will be produced. So coal produces more air pollution than oil, and oil produces more than natural gas. That's important to understand. And then there's those three different types of coal as well, the dirtiest and then the cleanest, right? So the bituminous, the anthracite, drawing a blank right now. Yeah, I'm doing this on the fly, so this is what happens here. Where the heck's, I might as well finish my thought on that. Where the heck is that here? It's back in the other unit. Sorry, guys. This is what happens when you just kind of, what's that phrase? Shoot first, ask questions second. Lignite. Lignite's the dirtiest coal. Bituminous is the intermediate. Anthracite's the cleanest, but they're all dirty. All right. Anyways, back to this. So there's NO2, NO, carbon oxides. Carbon monoxide is when you have incomplete combustion. If combustion was perfect scenario, you would only get CO2 and water, but that's not the case. You also get nitrogen oxides, you get carbon monoxide, and my little fiasco with that at my house is a good example. I use natural gas, but it wasn't combusting properly, and it was just building up, right? So that is a major problem. And if it gets high enough and you can't tell, right? It's odorless, colorless, but you could get dizzy and nauseous and really tired. But you get enough of that, you can die. So that's scary stuff. Again, CO2, burning fossil fuels, and CO2 obviously right now is the biggest problem we have as a greenhouse gas in the atmosphere. Even though methane has a higher index for a greenhouse for like keeping the heat in. But CO2 is the biggest problem here. So then we have your particulate matter as well, right? You have PM10, PM2.5. PM2.5 is smaller. That can really get into your respiratory system and cause, all types of problems. Lung cancer would be the, worst case, I suppose. But any kind of respiratory illness can be caused by any air pollution, but particulate matter, especially 2.5. Very dangerous. That can come from volcanoes and fires, but primarily particulate matter is from when we're burning. It can come from road dust, as you can see, and exhaust. But if you burn biomass, you get a lot of particulate matter. Okay, so that's a problem in developed countries because they use a lot of wood or charcoal, let's say, for burning, for heat or cooking. All right, so there's some sources there. Let's talk quickly about ozone and smog. So, real quick here, you got your sulfurous smog, which is the grayish. That's with sulfur dioxide. Photochemical smog, the LA type. That's the brown smog. That's the one we're more familiar with. But again, that the color is just because of the type of chemicals in it. But smog is a problem because of the nitrogen oxides, NOx, and the SO2 mixing with other chemicals and VOCs, which we will get to here. So let's see here. Trying to go quick here. All right, we'll skip through that. Here's the VOCs. We'll come back to right here. I'll get to the formation of ozone and smog in a minute. So VOCs, organic compounds, when fuels evaporate, solvents, improper combustion of gas. That's where VOCs come from. And volatile organic compounds are a problem. Trees can produce this, like that scent of a Christmas tree, let's say, is a VOC, right? But in the natural process, without anthropogenic activities, without humans adding more VOC, everything's basically steady state and stable and at equilibrium, right? We're kind of throwing a monkey wrench in that with all the fossil fuel we were burning. Let's see here. Primary pollutant, I don't like the order of these, but that's fine. Primary pollutant, that's like directly out of a smokestack, right? Or exhaust pipe out of the car, right? And you can actually measure that, right? If you wanted to kind of compare a diesel engine to a regular gasoline engine, two different cars or trucks, you could put like a sock around the tailpipe and let it run for 5 minutes on the diesel and then on the regular gas car, and you could do a qualitative thing, right? Just see how it looks, which one looks dirtier. You could also, there was a lab that we could have done where you put a bag around it and then you can measure the CO2 that's trapped inside the bag. There's other tests for pollutants, just kind of running with this in my head here. There's these things you can stick on the walls of buildings or outside your house even, and it changes color with different levels of ozone. And we could do that here at my house in the city, and we could do that at school and your house. We could have done that. Would have been cool. So those are like little things, mini experiments you could do to kind of, get a grasp on the pollutants in the air, right? So again, primary is, wrap something around the tailpipe. So that would be interesting to do. So anyways, we talked about those types. Secondary is when it's undergoing a transformation, right? So O3, sulfate, nitrate, which ultimately come from acid rain. So if you look here, your primary and then your secondaries, once these start interacting with light and water, then you're forming ozone, you're forming sulfuric acid, nitric acid, and then when it's acid deposition, you're getting nitrates and sulfates as well. All right. So I think I can skip through a lot of this here. Vehicles and transportation is a major, major source of pollution. The Clean Air Act has helped with that for sure, but we still need to get better. The EPA with their standards as well, National Ambient Air Quality Standards. And if you look at this here real quick, CO and NOx, mobile transportation is the biggest one. Sulfur dioxide, it's power plants, right? Because you're not using coal in your car, obviously. Particulate matter, burning biomass is a big one. Dust is a big one. Ag is a big one. But fires by far there, whether it's natural or human-made. This is good to see. Things have decreased since 1990, but still too high, right? I mean, the CO2 levels are still too high. Okay, here we go. Rip through this kind of quick. I don't know how well you can see this, but in a natural situation without VOCs, which we'll get to, NO2, even from us, anthropogenic, reacts with sunlight, breaks apart. You get NO and O. The O's that are free radicals combine with O2 to form ozone. That's natural. It happens all the time. But then it reverses when the sun goes down because there's no sunlight for that to happen. It's a certain wavelength of light that makes that happen. So when that's gone, it reverses. So this is a fairly steady state, equilibrium, if you will. We screw it up. One, we're producing way too much NO2, right? So we have too much of that. And then VOCs love to react with NO. And when they do that, that disrupts this whole process, and we're forming photochemical oxidants. Things like ozone technically is a photochemical oxidant, PANs. That's another one. Aldehydes, ketones, different organic acids. So just nasty stuff. And when that reacts with and mixes with ozone, you get smog, right? So you get your NO2 creates smog. The VOCs mix in there. So the chemistry of smog is actually very complex. I think from reading, different sources that people don't, chemists, scientists, whatever label you want to give them, don't fully understand all the chemistry involved. It's bad, right? It's bad. If you have enough smog, it blocks light, and it's low to the ground, so you're breathing it in, and it's a major problem, right? So as long as you understand the rough process here, ozone, and this is tropospheric, right? We want it in the stratosphere to block ultraviolet. We don't want it down here where we live. So it reverses itself normally, but we're, with our burning fossil fuels and all our VOCs, are kind of screwing that up. All right. We talked about that the other day. We don't need to get through that. Acid deposition. We had a question about that. So I'm going to skip through this quickly. But again, it's really from SO2 and NOx, sulfuric nitric deposits, rain, hail, sleet, snow, whatever, any sort of deposition that has the ions in it, and the acid that causes a slew of problems, right? Okay, let's see here. All right, so yep, we've talked about this before. Okay, especially aluminum is leached out, metals are leached out. It decreases pH and maybe outside their tolerance range, damages buildings, monuments. Okay, pollution control measures. Again, the Clean Air Act helps with that. But the biggest thing here is, avoid the emissions in the first place. That's the unit before this, actually, energy, which we will talk about in a review class. So yeah, first is using alternative, right? Renewable electric cars, for example. Natural gas instead of coal. If you're going to use fossil fuels, use cleaner, right? It's way cleaner. Let's see here. Efficiency and energy efficiency and conservation, right? Use less fuel, right? If you can use less fuel or have more efficient vehicles, let's say, machines, whatever's using the fossil fuel. And then, control pollutants. So you have regulations, legislation, the Clean Air Act, you have cap and trade, which I'll show real quick. Different types of technology like scrubbers, right? Where the heck is that? Down here? Scrubbers on smokestacks. So that's like last resort. First thing, stop using them. Okay, you got to use them. Use cleaner versions of it. Then while you're using cleaner versions, have more efficient use of that fuel. So you don't have to use so much. You're not producing as much pollution. And then worst case, you're still doing all those things. Try and limit what comes out of the smokestack, for example, or the tailpipe, right? So I'm not going to go through every single one of these, but scrubbers we talked about the other day, catalytic converters, they take NO and NO2 out and CO out so that it's not spewing into the atmosphere. It's pretty much just CO2 and N2, which is still not great, but better than the alternative. Okay, let's see here. Again, this is just kind of showing some options municipalities have tried to reduce pollution measures. Some work, some don't. Limit automobile use every other day. Increase public transportation use. Especially if it's electric, let's say. And then people say, well, where's that electricity coming from? Is it a power plant using coal? There's kind of always trade-offs, but you saw way up here. Let me go back. Mobile transportation is the biggest one. Oops. Oh, you saw it. Yeah, right here, right? So transportation, right? So if you can stop using cars so much and use public transportation, that might be electric, let's say, or even if it isn't, you get a whole bunch of people taking a bus instead of everyone driving their own car, then that's much better. All right. Where was I? Sorry, guys. We were there. Okay, I'm going to skip this. We talked a little bit about that. You guys did some research on your own. Okay, indoor pollution. So you got radon, you got CO, you got asbestos, you got VOCs, right? So carbon monoxide, asbestos, radon, comes up through cracks. VOC is from all the synthetic material in your house. CO is, again, incomplete combustion. So indoor air pollution is a major problem, especially in developing countries who are burning biomass for cooking, open pit fires right where they live, right? So that's lots of particulate matter and pollution. So if we have new houses that are more airtight, or buildings, you have what's called the sick building syndrome, and that's because there isn't really proper ventilation. You have chemicals coming in from outdoors, chemicals indoors. I'm not going to go on and on about that's the last slide anyway. Developed countries, this is the biggest problem. Sick building syndrome. Developing countries, again, it's from burning biomass in the house or where they live, and that's a big problem for developing countries. So okay, so solutions to these problems, I kind of briefly talked about it, but let me show you again real quick this cap and trade. Again, this is very specific. Who knows if it's going to be on the test, but I feel like it's good to go through one more time. So the basics here, essentially, is the government says, all right, you have a certain amount of CO2 that you can emit when you're running your power plant this year. And the total amount permitted becomes the cap. Companies are taxed if they produce higher levels of emissions than the permits allow. Companies that reduce and don't need those permits can trade them or sell them to other companies who might need them. But the trick here is the government lowers the number of permits each year, thereby lowering the total emissions. So it makes the permits more expensive, and over time, companies have incentives to invest in technology that's cheaper, right? So you can buy scrubbers or just maybe change what you're burning instead of coal, right? So, and then, you can go on and look at this stuff here. But that's it. I'm going to stop there. So that was it. That was my quick run through of pollution. It's tied into the energy unit with renewable sources instead of using fossil fuel, because burning fossil fuel is the biggest problem with air pollution, right? So I'm going to stop the video, and that's it.